I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Today, we'll learn about polynomials, their characteristics, look into the graphs, zeros, and x-intercepts. What are polynomials? What is the difference between zeros and x-intercepts? How do we relate graph to equation, understand end behavior of polynomials, analyze degree and leading coefficients, sketch polynomials in factored form? These are some of the topics which will be covered in today's lesson. I hope you will enjoy it. You will appreciate our approach, engaging minds in this lesson, where the creative thinking and problem solving skills are developed while we connect with the context, visualize strategies, and apply our learnings. All this will help us to bridge the gap and understand polynomials better. Gain the confidence. Get ready for future. We develop both mathematical and social skills. I can be part of your success story. Build strong foundation and ensure bright future. That is the gift of education. You can always contact me on the email address given. Join my classes. Now, let us enjoy the lesson with the brilliant student Aryan. Hi Aryan, how are you doing?
Hi, sir. I'm doing good. How are you doing?
Very good, very good. So today, what do you want to learn?
Yeah, today I want to work on the new unit that we started in this class in math,
Okay.
which is
So
polynomials.
what happened to your last test?
Yeah, I got a 98 on the test.
98. Excellent. Very good. That is how you should be performing. We expect that from you. So grade 8 student getting 98% in grade 11 mathematics. I love it. Okay, so today you want to learn about polynomials. So can you tell me exactly what all you want to learn in polynomials so that, I'll have a frame of mind to explain you everything.
I put everything in the Google Drive folder.
Is analyzing graphs of polynomial functions, right?
Yeah.
Perfect. So some graphs are given to you. You need to analyze these graphs.
Yeah.
What it really means is, I'll explain you all this. You see the degree of the polynomial in this? Sometimes 2, sometimes 3, sometimes 4. So the
Yeah.
leading coefficient, the highest power, is the degree of the polynomial when they are written in standard form, right?
Yeah.
And based on degree, you could have the graphs as shown here.
Okay.
And then we have some questions. How many turning points can a graph of polynomial function have? Is it possible to sketch a graph of cubic polynomial that has no turning points, right? So there are some questions based on this. Correct, right?
Yeah, I can see it. I can see it.
So if you have x squared, then which graph will it correspond?
It's going to be like it's a parabola.
It's a parabola like this, right? So square function, you may have to just figure out which parabola actually it is, right?
Yeah.
So in short, I can summarize this learning with some basic concepts. And that is to say that, if you look into this particular graph here.
Yeah.
So it shows this is a quartic function. Let me write quartic. Means degree 4.
Yeah.
And since both sides are up, we'll say the leading coefficient is positive. Is it okay?
Yeah. Yeah.
So an is greater than 0. So an is the leading coefficient. So the coefficient for x to the power of 4 is positive. Now this corresponds to a cubic function, right?
Yes.
Now right side is down. So if right side is down, that means the leading coefficient is negative, is less than 0. Does it make sense to you?
Yeah.
So D will correspond to this D, right? And this is degree 4, so E will correspond to B. Does it make sense?
Yeah.
Now, this cubic function, as you see, has a leading coefficient is positive. So this will be cubic positive, so that C corresponds to A.
Yeah.
So likewise, this is a degree 5, which we can see will be on the next page. And so we can correlate these things, right?
Yeah.
Not a difficult issue. I would like to actually tell you how do we relate these things so that any graph given to you, you are in a position to find the answer. Okay?
Yeah.
So I'll clear this and now take a whiteboard. Take a whiteboard. Stop sharing.
Yeah.
That will be better for me. So I'll explain you the concept on a whiteboard. So let's begin by understanding what a polynomial is. So polynomial function is of the form an x to the power of n plus an minus 1 x to the power of n minus 1
Okay.
like this, right?
Yeah.
Let us say a2 x squared plus a1x plus uh, just some constant. Let me write a0.
Yeah.
So that is the polynomial. In any polynomial, very important term is the leading term. So these are each terms, right? So this is
Yeah.
the leading term. And En is called the leading coefficient.
Yeah.
Leading coefficient. And n is the degree of polynomial.
Yeah.
So n is the degree of polynomial. So highest, these are all the terms. These are different terms, right?
Yeah.
So normally, in a degree n, you have n plus 1 terms.
Yeah.
Maximum. Perfect. So that is what a polynomial is. And remember that n belongs to set of whole numbers.
Yeah.
This is very important for any polynomial. So n cannot be like radical or a square root or negative, correct?
Yeah. It has to be a number.
All right. So if I write some function, let's say function f of x equals to square root of x, it is not a polynomial.
Yeah.
Okay.
And I think
Now,
it's also because the word poly itself means like multiple.
yes.
Yeah.
So one term is monomial, two terms binomial, three terms trinomial, and then we say polynomial, right? So
Yeah.
name of the polynomial is based on the degree. So
Yeah.
if degree is 4, we say quadratic. If degree is 5, pent. So we have with the degree, right? So the polynomial terms. Let me clear the screen and get to the graph of polynomial.
Yeah.
As you can see, the degree could be even or odd. Is it okay?
Yeah.
So degree, let me write odd or degree is even. So we will take lines, which is degree 1, as a very special case, right? And constants, right? So we'll consider that also, right? So we'll also consider constant. Constant is a polynomial. And line is also a polynomial. But they are special cases because for a constant and for a line, we do not have a curved graph, right?
Yeah.
A constant will give you a graph which does represent a polynomial. For example, if I have y equals to 4, so it will be this line, right? Y equals to 4. Is it okay?
Yeah.
Which is a straight line. And for a line, also it is a straight line, but the lines could be diagonal, vertical, or something like this. Correct? So
Yeah.
in general, y equals to mx plus b, right?
Yeah.
So x degree is 1. It's a polynomial of degree 1, right? This is a polynomial degree 0. So let's write down the degree here. Degree for a constant is 0, right? And degree for a line is 1.
Yeah.
So now we get to even and odd degree. So, well, of course, 0 will be considered even, right? But we'll normally mention this as from 2, 4, 6, 8, and so on. And odd degree will say 3, 5, 7, and so on, right? So these are actually curves.
Yeah.
So I'm writing constants and line separately. These are polynomials. However, they are
Yeah.
straight lines, not curves. And therefore, I've split the rest of them as even and odd. Is it okay?
Yeah, I get it.
So when we talk about odd degree polynomials, in that case, the behavior depends really on the leading coefficient. So I'm writing that leading coefficient as an. If an is positive, that means greater than 0, positive, right? In that case, the curve will be right side up. Do you see that?
Yeah.
And the left side will be down.
Yeah.
So for odd degree, this is called end behavior. End behavior really means what happens when x approaches positive infinity and what happens when x approaches negative infinity. You get the idea. Ends at the two ends. So we say that an odd degree polynomial with leading positive coefficient actually goes from quadrant 3 to quadrant 1. Do you see that?
Yeah.
So anything it could happen like this or whatever, it goes like this. On the other hand, if I have a polynomial, even degree with leading coefficient positive, then right side is of course up as in the other polynomial with odd degree. So right side is always up if leading coefficient is positive. Remember that. However, for an even degree, both same ends. So we say both same ends, right?
Okay.
And in this case, opposite ends. So when you look at a polynomial, first thing, look for the degree. If the degree is odd, then we know it is behavior is opposite ends. If degree is even, same ends. Now, look for the leading coefficient. If the leading coefficient is positive, then right side is up. Okay?
Yeah.
And of course, if right side is up, even degree both are up, odd degree left will be down.
Yeah.
If leading coefficient is negative, in that case it flips over the x-axis and right side will be down, correct?
Yeah.
So that is how you have to see the behavior or the curve for any polynomial. So it is
Yeah.
always a continuous graph. So let me now clear all this and write down few characteristics. We are looking for continuous graph, right? Now, once again, if you look into even and odd degree,
Yeah.
let me write odd here. Last time I wrote here, right? Even. So as I was saying, we could have graphs which could be kind of like this.
Yeah.
Now, if I draw these kinds of graphs, it is very clear that on the right side graph, my leading coefficient an is less than 0, right? Because the right side is down, correct?
Yeah.
And here an is greater than 0 because the right side is up. And this is definitely odd degree because both are on the opposite ends. You get the idea?
Yeah.
Correct. So that is how we have to look for matching polynomial equation with the graph. With the leading term, you can actually match it. Perfect?
Yeah.
Now, I was looking at the questions. Now, let's talk about turning points.
Yeah, that's what I was like more confused on. Like how to like draw them out.
Turning points.
Yeah, the turning points, exactly.
So let's take one by one. So let's consider a cubic equation. Cubic equation means what? It really means that there could be maximum 3 zeros, right? Do you understand?
Yeah.
So this could be a cubic equation. Is it correct?
Yeah.
We could also have a cubic equation. So this will have three zeros. Now,
Yeah.
since there are three zeros, the number of turning points will be one less than the number of zeros, correct?
Yeah.
So we also see types of zeros. So what we have here is three linear zeros.
Yeah.
Linear zeros means, let's say this is at -4, this is at 1, and this is at, let us say, 3. That means this equation could be of the form x plus 4 times x minus 1 times x minus 3. Because these 3 points will give equation a 0 for these points. You get the idea?
Yeah.
If I know this particular point here, then I can find the value of a. Otherwise, this is treated as a family of curves. You get the idea? So
Yeah.
polynomial family of curves is with a. Now, if I specify that this particular point here is, let us say, 24. Let us say. In that case, I know for x equals to 0, y is 24, right?
Yeah.
So I can find the value of a. So I know that 24 is equal to a times 4 times -1 times 3 minus, right? So we can calculate the value of a as 4 times 3 is 12. A is equal to 2, right? And therefore,
Yeah.
my polynomial function, let us say f of x, is basically equals to 2 times x plus 4 times x minus 1 times x minus 3. Do you see that? We
Yeah.
have actually found the equation from the curve. You get the idea.
Yeah.
And in this case, you can see that all the three zeros are linear in nature. When I
Yeah.
say linear, it means what? It means it will cross the line like a straight line. Do you see that? Cross the x-axis like a straight line. So, if there are three linear zeros, how many turning points do I have? Two.
Two.
One less than the number of zeros. You get the idea.
Yeah.
So in a cubic equation, maximum, you could have three zeros. If the degree is 3, you could have three zeros, correct?
Yeah.
So three zeros will mean maximum of two turning points. Is that clear to you?
Yeah.
Okay. Now the question is, can you have a cubic equation without a turning point? Can you answer this question? You have to go from quadrant 1 to quadrant 3, right? Because
Yeah.
let us say leading coefficient is positive. So how can you go from 3 to 1 without turn? You can, of course, go, right? You can go. You can go like this. Do not turn, stop, and move forward. Do you see this curve? This
Yeah.
curve is like x cubed. All the three zeros are at one point, which is 0. X cubed. Do you see three zeros at one point? So
Yeah.
this zero here, we say this 0 is of order 3, because effectively it is what? It is x times x times x. Multiplicity of 3, we say sometimes. We say multiplicity of
Yeah.
3. All the three at the same point. Now, since all the three zeros at the same time, the curve does not have to turn to come to that point. It will just stay there and move forward, correct?
Yeah.
So this kind of a curve at the 0 will be like tilde. This sign we call it tilde. Do you see that? It is like curve like this, which really doesn't turn. Technically, we call this point as point of inflection.
Okay.
Next year in calculus, you're going to study this point as a point of inflection, and it is also called saddle point. It looks like a saddle, right, on the horse?
Yeah. Yeah.
So many times we do refer to this point as a saddle point. We say point of inflection when we talk about calculus, and you can see it is not a turning point. So you have a cubic function without a turning point. X cube is one of the examples. X to any degree 5, x to the power of 5, correct, will not have any turning point, correct? I could have even this function. Let me sketch another function here
Yeah. Okay.
like this. Do you see this function here? Now let's say this 0 is at minus 3. In that case, the equation could be x plus 3 to the power of, let us say, 7 odd degree. But it is all the zeros, 7 of them are at one point which is minus 3. You get the idea?
Yeah.
Multiplicity here is 7 for the 0 at minus 3. You get the idea? But
Yeah.
so you could have odd degree function without a turning point for sure. Is that okay?
Yeah.
So let's clear the screen and learn more about turning points and x-intercepts and zeros. Now there are many related intricate things. We are looking into 3 terms now: x-intercepts,
Yeah.
zeros, and turning points.
Yeah.
Can you tell me what is the difference between x-intercept and zero?
Yeah. So zeros are the x values that can complete the equation,
Okay.
and then x values are the points of the zeros on the graph.
X-intercept and zeros, what is the difference? Let me tell you one thing. X-intercepts are real zeros. So basically,
Yeah.
if I have, for example, you have a quadratic equation. Let's say we have x squared plus 1 times x squared minus 1. Do you see this equation, right?
Yeah.
How many x-intercepts will this have?
Ooh.
X squared plus 1 is always positive.
Yeah.
No zero for that term. But x squared minus 1 could be factored and written as x plus 1 times x minus 1, right?
Yeah.
That means there are 2 real zeros, one at plus 1, the other one at minus 1, correct?
Yeah.
If you use graphing calculator, when you see its graph, you will only see 2 zeros. So this example gives me 2 real zeros. However, there are 2 other zeros because of this, which are imaginary.
Yeah.
So as
So
far as zeros are concerned, there could be real zeros or imaginary zeros. The real zeros are x-intercepts, which you see on the graph. You get the idea.
yeah.
So x-intercepts are actually the real zeros.
Yeah.
That is one difference. And the zeros could be real or imaginary. Do you understand?
Yeah.
Now, if the polynomial is of degree n, then it will always have n zeros. You get the idea?
Yeah.
So when we talk about polynomials, so degree n means n zeros. Some of them could be real, some of them could be imaginary. Imaginary zeros are always in conjugate pair, plus and minus. You get the idea? Plus minus.
Yeah.
You know, minus 1. When that comes, you get iota, I, imaginary number. That gives you 2 zeros. So imaginary zeros are always in pairs. So now what we learn here is that zeros could be real or imaginary. X-intercepts are the real zeros only, right? So one huge difference. Second, zeros have order or multiplicity. Zeros have order. Or sometimes we
Yeah.
say multiplicity. Strictly speaking, x-intercept is a point where the curve touches or crosses x-axis, correct?
Yeah.
But zeros define how the curve will cross the x-axis or behave at the x-axis. You get the idea? Zeros, multiplicity of the zeros. Now let's get to this point. If I have the term, let us say x plus 3, in that case, at minus 3, I have a linear zero. Do you see that? It will cross the curve like a straight line at minus 3, right? However, if I have the term x plus 5 whole square, it means what? It really means that at minus 5, it will be like a parabola. Do you understand?
Yeah. Yeah.
So it is of order 2 or multiplicity 2. The behavior is the turning point on the x-axis itself.
Yeah.
On the other hand, if I have x plus 1 cube, then that means the curve could be going like this. Do you see that?
Yeah.
Order 3. So these are 3 different type of zeros, but all are only one x-intercept. You get the idea?
Yeah.
So that's a huge difference between zeros and x-intercepts. Now let's get back to turning points. Turning points, between any two zeros, there will be a turning point, correct?
Yeah.
So let's go to, let me take a new page so that I can talk about turning points in more detail.
Yeah.
So if I have zeros, let's say these are my zeros, right? And a polynomial has to go through these zeros. In that case, for sure, if I start from here, I have to go through this zero. I have to turn, then again turn, then again turn, like this. Do you understand? So my number of turning points are how many? Well, between two, I got one. I should write not one here. You may think this is like the coordinate point, but I have one turning point. I have second number of turning point, third turning point, correct?
Yeah.
We have 4 zeros. I should say 4 linear zeros. And we have 3 turning points. Is that okay?
Yeah.
Now think like this. If all the zeros are not linear, then what happens? Let's clear this. And make it smaller, couple of them. So we have taken one example where we have linear zeros, right?
Yeah.
So let's write how many zeros we have and how many turning points.
4.
So you have 4, and we are saying multiplicity of 1. We are not writing anything.
Yeah.
The turning points is 4 minus 1, which is 3. Does it make
Wait,
sense?
so couldn't also like couldn't there be more zeros as well? Because sometimes it's like function like with polynomials we have imagine like we have complex zeros.
Yeah.
Yeah.
Maximum 2.
Yeah. On the screen is it's just 4.
So number of zeros, let me first talk about number of zeros, is maximum equal to degree of polynomial. Is it okay?
Yeah.
And as far as minimum is concerned, then for minimum 0, it is 1 for odd degree.
Yeah.
And none for even degree. Is that clear to you? As far as number of zeros range is concerned, for an odd degree polynomial, it is from 1 to n. Is it okay?
Yeah.
Number of zeros. And for even, it is none to n. Because as you are saying, for a parabola, I could have a parabola which is kind of like this, no zero, right?
Yeah.
I could have a parabola which is like this, 1 0. I could have a parabola which is kind of like this, 2 zeros.
Yeah.
But maximum is 2 only, right? So the number of zeros for a parabola is 0, 1, and 2, correct?
Yeah.
Because the degree is 2, correct? Similarly, for even 3 degree, we could have number of zeros as 1, 2, or 3. You get the idea? Not
Yeah.
0. Because now, for an even degree polynomial, you realize that even degree has to go from quadrant on the top to top, right?
Yeah.
Let us say if I have to move from quadrant 2 to quadrant 1, I can go without crossing the x-axis, correct?
Yeah.
Therefore, there is a possibility of having number of zeros, real zero, x-intercepts we're talking about.
Yeah.
So these are the x-intercepts, mind it. As far as zeros are concerned, always 2. Always 2, how? We have here order is 2. Do you see order is 2? There are 2
Yeah.
zeros at this point. So as far as zero counting goes, we have 2 zeros here, we have 2 zeros here, and we have 2 zeros here also. Both are imaginary.
Yeah.
X-intercepts counting will say 0, 1, and 2. So that is a huge difference. You get the idea. So real zeros are x-intercepts. Is that okay?
Yeah.
Correct. Now, let's get to a formula. Do we have a relation between the number of zeros and the turning points? Very important.
Yeah.
Relation between number of zeros. So we are talking about zeros means x-intercepts for this. Is that okay? Real zeros, right? That will make sense, right?
Yeah.
To between real zeros and number of turning points. Is that okay? Now,
Yeah.
what have we realized so far is if I have, let us say, a function which is x times x plus 2 whole square times x minus 3 whole cube. Let us say. You see this function. In that case, we have zeros at which point? 1, 0 is at 0, right?
Yeah.
The other 0 is at minus 2. The third one is at 3, right?
Yeah.
Now let's look into multiplicity.
Yeah.
What is the multiplicity of 0 at 0?
0, right?
1.
Oh, sorry. Yeah. 1.
Here, you have to check the degree. 2. Here,
Yeah.
Do you see that?
Yeah.
Right? So, degree 3. Here, it's a positive leading coefficient, so an is greater than 0, correct?
Yeah.
What is the degree? 1, 2, 3, 4, 5, 6. Degree is
Yeah.
6, right? Even degree, right?
Yeah.
I'm trying to teach you how to sketch polynomials.
Yeah. Yeah. Yeah.
Even degree polynomials, an greater than 0 means right up. You see the end behavior?
Yeah.
And therefore, even degree means both same ends, correct? Now look here. This 0 at minus 2 is of order 2, right? Means when you hit the curve, it will turn because like a parabola. Order 2. The
Yeah.
0 at 0 is linear. So to reach that 0, I have to turn in between, right? But when I hit, I have to go like a straight line. It's a linear 0. The third 0 is cubic. So I'll go like a saddle point. You get the idea?
Yeah.
And my curve will be like joining these points. So let me just join them and show you.
Okay.
So that's the polynomial function of degree 4 with the given zeros, which I have drawn. Does it make sense to you?
Yeah.
Now let's look into the turning points. Can you tell me how many turning points are there in this?
5.
Only
wait.
3.
Oh, wait. Yeah. 3. Sorry.
Only 3. There are how many zeros? 1, 2, 3 zeros. There are 3
Yeah.
zeros, but 3 turning points. Last time I said there is one less turning point, correct? When there are
Yeah.
linear zeros. Reason is this, we have one, do you see this 0? We have a turning point because we have an even degree 0. Do you see that?
Yeah.
So even degree, I should say even order, because degree word is confusing. We normally associate degree with the degree of polynomial. So even multiplicity leads to additional turning point. That is why we have one extra. You get the idea?
Yeah.
So we had 3 zeros, right? 3 x-intercepts minus 1. So those are the number of turning points. We're trying to get the formula for turning point. Plus, how many are with multiplicity of even? 2, 4, 6, 8, 1. So we add. So what we get here is 3 minus 1 is 2, 2 plus 1 is 3. We have 3 turning points. You get the idea?
Yeah.
So this is a very good formula for finding turning point. Let me summarize this. So number of turning points I could always write as number of real zeros minus 1 plus number of even multiplicity zeros. You understand?
Yeah.
For example, let me write on a polynomial now, right? I'll write a big one. X plus 7 to the power of 6 times x minus whatever we'll write. Okay, don't worry. X plus to the power of 4, let's say x minus 3 plus 3. Let's make this as 2, and then we have x plus 1 times x, correct? Oh,
Yeah.
we've got a big function. Now tell me, what are the number of zeros?
6.
Oh, I undo. Okay. How many zeros are there? I should say real zeros, x-intercepts, okay?
Okay.
Real zeros. So x-intercepts.
Yeah. 6.
So 1,
Yeah.
2, 3, 4, 5, 6, right?
Yeah.
Correct? So number of turning points will be 6 minus 1, correct?
Yeah.
Plus, how many of them are even? 3 of them are
Yeah.
even.
3. Yeah.
Plus 3. You get the idea? Plus 3. And therefore, the number of turning points for this will be 6 minus 1 is 5, 5 plus 3 is 8.
Yeah.
You get the idea, right? We'll now sketch one to verify. Is that okay? We'll sketch.
Yeah.
Okay. So I'm writing a function f of x as equal to x times x minus 1 square, x minus 2 cube, x plus 3 to the power of 4, and let's say x plus 7 to the power of 6. We just wrote, right? It doesn't really matter.
Yeah.
Now, the idea is to understand the concept. So nothing is to the scale when I sketch, but it's all.
Yeah. Yeah.
So let's write down how many zeros are there. So we say real zeros, right?
Yeah.
Real zeros. This one is at 0, right? This one is at 1. This one is at 2. This one is at minus 3. This one is at minus 7. If I put minus 7, it will become a 0, right? So we have one at minus 7, let us say. We have one at minus 3, let's say, right? We have one at 0 itself. We have one at 1, and we have one at 2. Perfect.
Yeah.
Now, let's figure out multiplicity.
Okay.
Tell me, first one. What is the multiplicity of the first one? 1, right?
1.
Here 3.
3.
Here 4. Here 6.
4. Yeah.
Now tell me, what is the number of turning points?
5.
So how many zeros? 1, 2, 3,
6.
4. 1, 2, 3, 4, 5 zeros.
Oh, it's 5 zeros. Oh,
5
you got
zeros
rid of
minus
okay.
1. Correct?
Yeah, 4.
And
I
how
thought it was
many
5. I thought it
zeros?
was 6 zeros. Like that. Yeah.
1, 2, 3, 4, 5. I just wrote a new equation.
Oh,
5
yeah.
minus 1.
It's so
Yeah,
simple.
earlier one was 6. Don't worry. This is
Yeah,
a new-
it just looks familiar.
I just wrote something. Okay.
Yeah.
How many are even out of these? 1, 2, and 3 are even,
Three.
right?
Yeah.
So we expect 4 plus 3, 7 turning points, right?
Yeah.
Let me sketch and show you 7 turning points just to verify. Is it okay?
Yeah.
So, end behavior, all are positive. Do you see leading coefficient positive? Since the
Yeah.
leading coefficient is positive, our right side will be up, correct?
Yeah.
What is the degree? So, right
6.
side up because an is greater than 0. Degree, count
Yeah.
them all. 6 plus 4, 10, 10 and 3, 13.
3,
What is
13, 12, 13.
16. 6 plus 4, 10. 10 plus 3, 13. 14, 15, and 1 here, 16, right?
Yeah.
So even degree means both same and behavior, correct? So
Yeah.
let's start with 7. So 7 has order of 6, correct? Which is even, correct? So if I hit this curve, I will have to turn because it is even multiplicity, correct? 6.
Yeah.
6 means to be very flat and then turn. Now at minus 3, again it is going to turn because the multiplicity is even, it is 4, right?
Your voice is breaking.
Okay. Is it better
Yeah.
now?
Okay. It's good now. Yeah. It's good now. It's good.
Okay. So at minus 3, what is the multiplicity of the 0?
It's kind of,
4.
yeah. 4. Yeah.
So it will again turn. At 0, the multiplicity is what? 1. So it will
1.
look like a line, linear. Do you see that linear line?
Yeah.
At 1, the multiplicity is 2, so it will turn. But you are below the x-axis, so you go back down. Is that clear to you?
Yeah.
At 2, the multiplicity is odd, like a saddle point.
Yeah.
And therefore, when I connect them, I can form my graph and see how easy it is to graph polynomials, right? So let's say
Yeah.
we are on this side and we have to go turn and then we have to turn, correct? We have to turn and we have to turn like a line, go there. You see the graph?
Yeah. Yeah. I see it.
Smooth curve. So when you do it, make a smooth curve. First mark all the zeros and their behavior depending on the multiplicity of those zeros. And now, please count the number of turning points. What do we expect? 7.
7.
1 turning point, 2, 3, 4, 5, 6, and 1, 7. Do you see the 7 turning points?
Yeah.
Do you see the turning points at the zeros where we have even multiplicity? Correct?
Yeah.
That is why we added those 3. So that is the formula which relates equation in factored form. Equation in factored form directly gives you the x-intercepts. And each multiplicity of the zero, when added, will give you the number of turning points. So the formula is real number of zeros minus 1 plus even multiplicity zeros gives you the turning points. Is that clear to you?
Yeah.
This formula is not given in any book.
Yeah.
Okay. Now, here is a great question. Thinking question for you. My question is find possible number of zeros for degree 5 polynomial. Tell me, what could be possible number of zeros for degree 5 polynomial? Tell me.
So, degree. Yeah. So it could be like. Wait, do you mean like degree, like as like the highest degree, or like the like combined degree? Like.
So it all depends.
Yeah, that's what I'm like
Highest
asking.
degree when you write in the factored form. For example, if I write
Yeah.
y equals to 2x to the power of 5 plus 3x to the power of 4 plus something, right? Plus some constant 7, for example. Then the
Yeah.
degree 5. You get the idea?
Oh yeah. That's what I wanted to know. Yeah.
With the combination of terms, then you see the term degree. But you could also write like x times x plus 2 times x minus 3, right? So here 1, 2, and then if I write 3 here, So the degree is 5. Do you see that? Because if I multiply all the x's, I'll get x to the power of 5. X, x squared, and 3, 5. You get the idea? So both of them are degree 5 polynomials, correct?
Yeah.
So it depends. If it is given in the standard form, in that case, you have to check the term with the highest
Correct.
degree. That becomes the degree of the polynomial. If it is
Yeah.
in factored form, then you add all the factors degree to get the, because they get multiplied.
Yeah.
Okay. So coming back to our question, if I have degree 5 polynomials, what are possible number of zeros? Tell me, please. Minimum, maximum, and in between.
Yeah. So
Yeah.
yeah.
Possible number of real zeros means we are talking about x-intercepts. Yes, sir.
Yeah.
Total number of zeros are always 5. Okay, remember that part. Okay, minimum x-intercepts for degree 5. It is going to cross because the behavior is going from quadrant 3 to quadrant 1.
Two.
And
Yeah.
then 0. So definitely minimum is 1, right?
Yeah.
And maximum degree is 5. That means there could be 5 zeros and 1 less, means 4, correct?
Yeah.
Turning points. Oh, sorry. We are talking about, wait. We are not talking only of zeros. So 5 zeros maximum. Is that okay?
Yeah.
So we are talking about zeros. Let me write down zeros, right? And now here we'll write turning points. Okay. Now, minimum is 1 0, maximum is 5 0. So you could have any number of zeros between 1 and 5, correct?
Yeah.
So we could have 1, 2, 3, 4, or 5 zeros, correct? Now let's talk about the turning points for degree 5, correct? How many turning points will it have? Minimum number of turning points is how much?
1. Oh wait.
0.
Yeah, 0. Yeah. Sorry. Yeah.
Because you could have a degree 5 equation which could go like this, correct?
Yeah.
For example, x to the power of 5. It does not have a turning point, correct?
Yeah.
Degree 5 equation, can it have one turning point?
Wait. It can. It can.
Can it have?
Actually, wait. No, it cannot. Degree
Because
5.
you have to go from 3 to 1.
Yeah.
Turn
That's right.
once, you have to turn again. Do you see that?
Yeah.
Because you have to reach
Yeah.
0. So turning point could be either 0, but it cannot be 1. So it will be 2, right?
Yeah.
Correct? Or can it have 3 turning points? If you turn again, you have to turn back. So if you have 3, it will have 4 turning points. So odd degree polynomial will have even number of turning points. You see that even number?
Yeah.
Even number of turning points. So for an odd degree polynomial, 0 to 4 means n minus 1. Do you understand? So 0 to n minus 1 for odd degree polynomial. Does it make sense to you?
Yeah.
Now, if I have even degree polynomial, then how many turning points? Let's say the degree is 10.
Yeah.
How many turning points? Tell me. Possible. Give me all
You
possible.
have 9 possible.
So all possible values. So it
That's what.
If you have one turning point, it cannot have two because it has to go from one quadrant to the other, 2 to 1, right? For example, if I am going from 2 to 1, if I turn once, it's okay. But if I want twice, I have to turn back. Do you see that?
Yeah.
So I have 1 or 3 or 5 or 7 or 9 turning points. Do you see that? So these are my possible turning points. This is minimum and that is maximum.
Yeah.
As far as maximum turning points formula is concerned, it is always n minus 1. As far as minimum is concerned, it really depends on whether the function is odd or even, correct?
Yeah.
So it is 1 for even and none for odd. Is this part clear?
Okay.
Correct? So that
Yeah.
is how we have to understand the polynomial function as a whole. Now I think you can connect any equation with any graph, right?
Yeah.
And also figure out, without actually sketching them, how many possible turning points are there if I give you a factored form of an equation, correct?
Yeah.
So that's where we're going to end today's lesson. I will
Okay.
like you to summarize the learnings of today's lesson on polynomials. Tell me.
Yeah. Yeah. So in today's class, we learned about polynomials and their graphs, and also how many like turning points, how to find a degree, how to determine the minimum and maximum number of turning points, and also how to find the zeros.
Very good. And you also learned the difference between x-intercepts and
Yes.
zeros. Zeros have multiplicity. Zeros define the behavior of the curve at the x-intercept. Correct? Very important.
Yeah.
Zeros could be real or could be imaginary. You get the
Yeah.
idea. Number of zeros in a polynomial is always equal to the degree of polynomial. You get the idea. But
Yeah.
the number of x-intercepts could vary. The x-intercepts maximum will be equal number of x-intercept maximum number of x-intercept could be equal to the degree of polynomial, and
Yeah.
minimum number of x-intercept really depend on whether the polynomial is of even degree or odd degree. For an even degree polynomial, there may not be any x-intercept, like a parabola, x squared plus 1, correct?
Yeah.
But for odd degree, 1 minimum x-intercept will be there, as they have to cross the x-axis. They are going from one end to the other. So that is
Yeah.
their end behavior, opposite ends. And
Okay.
given behavior for even degree, same ends, they can go without crossing the x-axis from one end to the other. You get the idea. So this
Yeah.
is, in short, the characteristics of polynomials, which will give you always a smooth curve.
Yeah.
Domain, all real numbers. Range, normal. We write all real numbers. But for even numbers, we do have absolute value of maximum or absolute value of minimum. Correct? So their
Yeah.
range is restricted if the degree is even. Is it okay?
Yeah. That's fun.
Perfect. So we'll end the class here and continue next time.
Okay.
All the
Okay. Okay. Thank you.
Thank you. Bye.
Good night.
You can always join my classes by writing to me on the email address given. I can be part of your success story and build strong foundation to ensure bright future.